All right, this example, you gotta love it when it says analyze without using your calculator. So we can't graph it to find out this information. So we have to kind of rely on our own abilities here. So my function is f of x equals sine x plus cosine x. All right, that doesn't look too bad, right? Find the x and the y intercepts. Find the x and the y intercepts. I already did that one. All right, so an x-intercept happens when y is equal to 0. So 0 equals sine x plus cosine x. So negative cosine x equals sine x. Okay, so this is where your trig knowledge has to come in. When is the cosine and the sine the same value? Right away I think of square root of 2 over 2, right? Okay, so square root of 2 over 2 applies to pi over 4, or 45 degrees. Now we need to think about the quadrants where the cosine is negative and the sine is positive. Or basically the cosine is the opposite sign as the sine. Okay, and that's going to be in your second and your, so thinking about this, that's going to be in this quadrant here and this quadrant here where our signs aren't going to match. So I want 45 degrees or pi over 4 here, and I want 45 degrees or pi over 4 here. So what this one gets me is that's pi over 4, 2 pi over 4, 3 pi over 4. So I've got x equals 3 pi over 4. So 1, 2, 3, 4, 5, 6, 7 pi over 4 is my next one. 7 pi over 4. So my two values for my x-intercepts are those two. Now my y-intercept happens when my x is 0. Okay. So what is f of x when, or I should say, what is f of 0? So the sine of 0 plus the cosine of 0. Well, the sine of 0, that's the y value of 0 degrees, is 0. And the cosine of 0, so it's the x value of 0 degrees, so that's 1. So that means my y-intercept is y equals 1. That's your y-intercept. Great. All right, so part 2, part B, says, we're going to go ahead and put boxes around here so we can find these later, because we're going to have to graph these in a little bit. So y-intercept. Okay. So then it says, find the intervals where the graph is increasing, decreasing. That to me says derivative. When we looked at it before, we were looking at acceleration and velocity and displacement. We said when is the velocity positive and when is the velocity negative. That's your increasing and decreasing. And we want the relative extreme points for that as well. So what I'm going to do is I'm going to find the derivative. So part B, I'm going to find the derivative. So the derivative is equal to, well, the derivative of sine is cosine. The derivative of cosine is negative sine. Okay, so let's go ahead and find out where this thing equals 0. Now, minus sine x. So let's add sine x to both sides. So sine x equals cosine x. All right, well, it's kind of the same deal. Here we're looking for the same value of the sine of x as the cosine of x. Still, I'm thinking of the square root of 2 over 2. But this time, they have the same sign. They're either both positive or they're both negative. Okay, so that's going to happen 45 degrees here, 45 degrees here, or pi over 4 here and pi over 4 here. So that's going to happen when x equals pi over 4. And that's 1 pi, 2 pi, 3 pi, 4 pi, 5 pi over 4. Okay, so we have those 2 points there. What we need to do is figure out which one's a minimum and which one's a maximum. Okay, so we have pi over 4, making a sign diagram for it, and 5 pi over 4. Okay, a number that's below that is 0. So the cosine of 0 is 1, and the negative sine of 0 is 0. So that gets me a positive here. Let's see what falls in between. How about pi over 2, or 90 degrees, right? So the cosine at 90 degrees is 0, and the sign is 1, so we do 0 minus 1 gives us a negative. 5 pi over 4, we could take that up to 4, 5. Let's take that to like 270, or 6 pi over 4, or 3 pi over 2. Okay? So I'm just thinking about the 270. I'm thinking about this spot down here. So the cosine of this spot down here is 0, and the sine of this spot is negative 1. So it's 0 minus a negative 1, so that would make it positive. Okay? So we are, to answer the question, we are looking at a pi over 4 would be plus then minus. So pi over 4 is my max. So my max is at pi over 4. I'll get the y-coordinate in a second. And my min, because this goes negative to positive, is at 5 pi over 4. And I'll get the y now. So I'm going to take pi over 4 back to my original function. The sine of pi over 4 is square root of 2 over 2. Right? So square root of 2 over 2. The cosine of pi over 4 is square root of 2 over 2. So this equals 2 square roots of 2 over 2. Or just the square root of 2. And the same thing will happen for this one. Okay? So we have our minimum and our maximum. And we can also say that it is increasing. It's increasing from, where did we start? We started at 0. From 0 to pi over 4. It's going to be increasing again from 5 pi over 4 to the end of the graph, which is 2 pi. And it will be decreasing in between those two. So from pi over 4 to 5 pi over 4. Okay, all of this stuff is going to help us make a very accurate graph of this function without a calculator. Find the intervals where the graph is concave up and the graph is concave down. Well, concavity is where we use the second derivative. So let's find the second derivative. Okay, so the second derivative. So what is the derivative of cosine? Well, that's negative sine. And what is the derivative of sine? Well, that's cosine. We just leave that minus sign between it. Okay, and we want to find out where those things are equal to 0. So negative sine x minus cosine x. So cosine x equals negative sine x. So this ends up being those same values of 3 pi over 4 and 7 pi over 4 that we already got. So x equals 3 pi over 4 and 7 pi over 4. So if I do my sine diagram, I can tell you the areas that it's concave up and concave down. 3 pi over 4 and 7 pi over 4. So a small one would be 0. I love to use 0 when I can. So the sine, or the y value of 0 degrees, is 0. So it's 0 minus 1. So I believe that gets you a negative number. How about pi? So pi would be 180 degrees, right? So we want the, again, 0. But now it's negative 1, so minus a negative will turn it positive. And then 7 pi over 4, well, we can take that all the way up to 2 pi. And that's going to be the same as it was at 0. So that's negative. So it would be, this would be concave down. Concave down. This would be concave up. And this would be concave down. Okay. So all of that was to be able to throw these points on a graph. There's one. There's one. And we were going from 0 to 2 pi. So let's go pi over 4s. 1, 2, 3, 4. So that's pi. 1, 2, 3, 4. So that's 2 pi. So that's 1. And that's negative 1. All right, let's throw some points on here then. So from our intercepts, we got 3 pi over 4. 1, 2, 3. And we got 7 pi over 4. 4, 5, 6, 7. And then our y-intercept we found was at 1. Great. All right, then we can go and do our minimums and our maximum. Our maximum point was at pi over 4 and square root of 2. Square root of 2 is like 1.4. So we're just going to estimate where that is on the graph. So pi over 4 and right about there is going to be my maximum. And my minimum is going to be at 5 pi over 4. That's 4 pi over 4. 5 pi over 4. And negative square root of 2. Was that right? I wrote that wrong. It should be negative square root of 2. Go back there and add that negative on there. Okay. And then we can see we're matching this concave up and concave down business. So it says concave down. That is concave down before that. That is concave up in between. And it will be concave down this way. So we're going to use that to draw our graph. Like so.